Hello everyone, welcome to my YouTube channel, and in this video we are going to solve another LeetCode question. The question number is 35 and the tagline is search insert position. The difficulty level of this question is easy, so I expect nothing crazy about this question. So let's just go ahead and maximize this window. We can view the problem statement a bit better. The question states that given a sorted array of distinct integers and a target value. So first of all, we will be given two things. The first one will be sorted array, and that array will be of distinct integers, and along with that array we will be given as a target value. Now we have to return the index if the target is found in that array. So it is very simple that if we will take that array, and we know that that array is sorted, and we will take that target value and we will look for that target value inside of that array. And if we find that target value inside of that array, then we'll simply just return the index of that value, which will actually give us the position or location of that value inside of that array. But if we don't find that target value inside of the array, then return the index where it would be if it were inserted in order. So basically we have our array sorted, and the question states that if we don't find the target value inside of the array, what would be the index value for that target value if we added that target value inside of our sorted array. We will go ahead and see examples to understand this question a bit better, but before that we have to check this condition out. We have to write an algorithm which have the runtime complexity of big of log n. Okay, so first of all we'll just go to the example number 1, and we have here an array which is called nums, and this array contains the integers and all of them are sorted, and along with that array we have a target value of 5. Okay, so we can see that we have this target value inside of this array, and the position of that target value in the array is 2. And what I mean by position is I mean to say that the index of that 5 is 2, because 1 is the first value of this array, so the index of 1 will be 0, and 3 will have the index of 1, so 5 will have the index of 2. But in the second example you can see that the target value is 2 and we don't have that value inside of this array. So what if we added this value inside of this array, and we know that this array has to be sorted, so this 2 should come after this 1, right, after this first value. So if the index of this first value is 0, then after adding this 2, the index of this 2 will be 1. So that is why we have this one in the output. Okay, now we can just go ahead and write an algorithm to solve this question. But before writing the code, we'll just go ahead and make a pseudocode, or we will try to understand the theory of this question. And for that we will use binary search method. What I mean by that is, in this case, for example, we have this array and we have a target value of 5. What we will do, we will take this first value as a pointer 1 and this last value as a pointer 2, and we will add these both values and we will divide them on 2 to get the midpoint of this array. Okay, so first of all I'll just add 1 plus 6, and 1 plus 6 is 7, and we will divide the 7 by 2 and we have the value of 3.5. And remember the array contained only integers, so we will just ignore this floating part, and we have this 3. So 3 is the midpoint of this array, right? I'll just go ahead and write the mid is equal to 3. Okay, what we will do, we will just compare this mid value with the target value. So if the target value is greater than this mid value, then we will ignore the left hand side of this array, and we will just look for this target value in the right side of the array, which comes after the midpoint, obviously. But in case we had 2 here, now this 2 is actually smaller value than this mid value, so we'll just go ahead and ignore this right side of this array, and we will look for this target value into the from the left side of the array. And that's how binary search actually works. Now to search this way, we have to update our pointers as well after each iteration. For example, if we have 5 here, and for example we have 3 here as a midpoint, we will compare these two values and we will know that the 5 is greater than the 3. So we'll ignore the left side of this array and we will search for the target value in the right side of this array, right? So for that, what we'll do, we'll just update our pointer, our left pointer to the mid plus 1 value. What I mean by that is in the first iteration, before getting this midpoint, our first or our left pointer was 1. But after finding the midpoint value and after comparing it with the target value, we know that we don't need this part of the array. So we will just go ahead and we will update our or left pointer to the next value of the midpoint. So we have this midpoint and we know that this is the lesser value than this 5. So there's no way we can find that 5 in this part of the array. So we'll just go ahead and take a pointer from this one and we will land that pointer on this 5, which is actually mid plus 1. Okay, so mid has the index of 1, so 1 plus 1 will be 2. So our left pointer will come on the 2th index, and our right index will remain on this 6. And in this case, we will have 5 plus 6, and we will have 11, and we'll divide that 11 by 2, and we will have 5.5. Okay, so we will ignore this floating part and we have this midpoint in the second iteration, and we will compare this value with this 5, and we will know that these are the same values. So we will just go ahead and return the index of this value. So that is how this problem actually works. What we will do, we'll just apply the same logic, the second example, so that we can understand this in a bit better way. So I'll just take this array again, and this time our target value is 2, right? So first of all, in the first iteration, our left pointer is on 1, our right pointer is on 6. So we'll just go ahead and 1 plus 6, which is 7, and 7 by 2, which is 3.5, but I'll just ignore the 0.5 part and I'll just write this 3. Now we have the midpoint 3. Now we will compare this midpoint with this target value, and we know that the target value is lesser than this midpoint. So we'll ignore this right side of the array and we'll look for the target value in the left hand side. And in this case, what we should do is update this right pointer and take it from here and assign this value which comes before the midpoint as the right pointer. And in this second iteration, our left pointer will also be the same. So we will have 1 plus 1, which is 2, and 2 divided by 2, which will be 1. So we have this 1 here, and we can find our value of 1 here at the start of this array. Now we know that this one is not what we were looking for, but it is actually lesser than the target value. Then our target value must come after this point, and we know that before, in the first iteration, we had 3 as the mid value, so it should come before this 3 and it should come before our 1. So naturally this 2 will come after 1 and before 3. And when this position is decided through the algorithm, we'll just go ahead and return the index of this value, which in this case will be 1. So that is how this code is going to work. Now we'll just go ahead and write the code for this. Now remember, earlier I said that we will take 2 pointers. The first one will be at the start of the array, and the second will be at the end of the array. So for example, we'll call them left and right pointers, and the left pointer should be at the start, so index value of the starting value is 0, and the right pointer should have len of nums minus 1. So len function actually gives us the size of the array, and minus 1 will give us the index of the last value. Okay, so after that we have to write a loop which will actually iterate through this array and look for this target value through the binary search. And after that we will just go ahead and write a condition which will keep this loop going, and the condition will be the left pointer should always be equals or lesser than the right pointer. And what I mean by that is, in the second example, we saw that our left pointer was also equal to our right pointer. Left pointer was 1 and the right point was also 1. So even after that, we were able to actually figure out that what should be the position of this target value too. After writing this condition, we have to find the midpoint of this array in each iteration, right? So I'll just write midpoint, and for that what we have to do is just add our left and right pointers, and after that divide them with 2, and in this way we can find our midpoint. Now after that we have to write the conditions through which we can return the index value of our target value. So first of all, we'll write a condition that if the target is equals to the nums mid, then just go ahead and return the mid, right? What it actually means is, do you remember that in the first example when we found the midpoint of the second iteration, then it became equal to the target value. So in that case, if the target value is equal to the mid of this nums arrays, then just go ahead and return the value of that mid or index of that mid. And after that we'll just write another if condition, and we will look if the target value is lesser than the midpoint of this num array. If that's so, then we have to ignore this right side of the array, and we have to look for the target value in the left side of this array, right? So I hope you remember that when we looked for the target value in the left side of the array, we updated our right pointer. So in that case our r will be equal to mid minus 1, and after that we'll write another condition, and we will write it as else, because first the target value was equals to the mid value, and after that the target value was lesser than the mid value. So else condition will be if the target value is greater than the mid value. So in that case our L will be updated. And I hope you remember that when we had the value, a target value greater than the mid value in the first example, then we actually ignored this left part of the array, and we looked for a target value in the right part of the array. And in this case, we actually went ahead and updated our left pointer instead of updating the right pointer, right? So we'll just go ahead and write this line, which will update our left pointer instead of our right pointer. Now after doing all that, we'll just get outside of this if condition, and after that we will also get outside of this loop, and we will return the L, which will gives us the index of the desired value inside of that array. So after that we'll just go ahead and try to submit this question and see if this actually works. Okay, so actually I made a little mistake here. The name of our array was nums, it was not num. So we'll just go ahead and click on the submit button again, and you can see the question has been submitted successfully, which means that this logic and this code actually passes all the test cases. So that is it for this video. If you like this video and if you learned something significant, do tell me about it in the comment section, and remember to like, subscribe and share this video with your friends.